So, on Valentine's Day, February 14th.
Happy Valentine's Day, Macy.
Yeah, happy Valentine's Day.
We missed you.
Alright.
Yeah, you weren't here.
Moving on. Today, we're talking about volume and surface area bright prisms. I call it lesson 9.2 because it's the second lesson in chapter 9 that we're going to cover. We are moving from cubes and cuboids onto prisms that are a little bit more interesting. They're made up of different shapes. There's two vocabulary words that we'll use a lot when we talk about these prisms, and it's bases and lateral surfaces. The bases are the two parallel faces. So in this first blue prism here, the pentagon on top is parallel to the pentagon on the bottom of it. Those pentagons are considered the bases of it. So when we're talking about the bases, we're talking about the two parallel faces.
I rhyme like it's a crime.
Okay. The other thing that we'll talk a lot about are the lateral faces. Okay, lateral means what? Do you guys remember? Cross or to the side, right? So lateral surfaces are the side surfaces. They are the ones on the side of it that connect the two bases. Lateral surfaces are the side faces that connect the bases. Yes,
Why
Connor?
are there like 3 lines?
Define.
Oh.
Also a symbol for definition versus equals. All right. How many lateral surfaces does our pentagonal prism have? How many lateral surfaces does it have? So how many are there going around the sides of it? Margaret? 5. There's 2 in front you can see, and then there's a third one back here, a fourth one back there, and a fifth one back there. So there's 5.
What about the one on the bottom?
That is not considered a lateral surface.
Oh.
That's a base. That's the other base.
Oh, okay.
Okay. All right. So we're going to talk about how we find the volume of these today. And I have 3 pictures here, a square prism, a triangular prism, and a hexagonal prism. And I'm showing them as stacks to see if that will help anyone figure out a good strategy for finding the volume. Let's just focus on the triangular prism in the middle. What might be a strategy for you to find the volume of this prism? Cuboids are doing length times width times height. What do you think we might want to do to find the volume of this? Just a guess, just some speculation. Capone? Find the area of the triangle. Find the area of the triangle. That's a good start, Connor. We find the area of the triangle, but we want the volume of the whole thing. What might we going to do? Please? Length times width times height cubed. You mean the height cube?
Yeah, like
All of it? Then we'd be like taking a cube and cubing it.
Whoa.
That would look like, that would be psychedelic.
that would be psychedelic.
It might be something from a 6th grade classes. All right. What if like each of these? Okay, so let's say we find the area of this triangle, and let's pretend like these are like kind of infinitely thin. What would make sense to get the whole stack? Mason?
Maybe count them up.
Count them up. But normally, and multiply it by how many there are. Is that what you mean?
No,
Like,
let's
count.
just go with that.
Count this up. No, nobody?
Yeah, let's do that.
Let's
do it.
So let's say we find how the area of this, but then we have a bunch of these, right? That would be like the height of it.
It's just like a bunch of like little pizzas on top of each other.
Stacked, and the height would tell you how many of them you have. So what you do to find the volume of any prism is find the area of the base. In this case, it's a triangle. Find the area of the base and multiply it by the height of the prism. like how many of those bases are in a stack in a sense. Alright, so the B is really generic. It will stand for the area of the base. So regardless of whether we're talking about finding the triangular prism or the hexagonal prism or a pentagonal prism, the B means whatever the area of the base is, find it and then multiply it by the height of the prism, and that will give you the volume. Okay? Questions?
No.
Alright, so make sure you get this. Yes?
Yeah, what's that little,
What if there's not what?
like, you know, there's like lines in these figures? Like, what if there aren't?
The stacks?
Yeah.
You just will have a dimension here, like it just might be 2.5 meters. Then you use 2.5 meters.
So you just do base times height? Oh, base.
Area of the base times the height of it. So let's apply it to a problem. Like this. Alright, go ahead and sketch this triangular prism.
Oh,
Right here, sketch this.
it's so hard.
I will sketch with you, so if you have a hard time, you could draw the back.
Art class.
Draw the back line of the prism first. And then there's different ways of doing it, but I'll draw the top part first. So the triangular base on the top. And then you can see these are vertical lines coming down.
Something. Wow.
That was actually really easy.
And then these should be pretty much parallel to those lines. So something like that. If you want to get fancy, you could draw that back hidden line in there. Okay. And then your dimensions on there is 20 is this length of this side of the triangular base. 9 is the height here, and then we know 12 is this side of the triangle, and 16 is that side. You have one drawn?
Oh, yeah.
Alright, so we're going to do two things. We're going to find the volume, and then we're going to talk about how to find the surface area also, because there's kind of a clever way to do that. So we said to find the volume of any prism. Really, we could say the generic formula is what? What could you find the volume of any prism? Lise? Yeah, and the capital B stands for what, Lise? Area of the base. What shape is the base in this problem? What shape is the base? Shape? Jack. Jack? It is a triangle. It's a triangle. So we're going to find the area of the triangle and multiply it by the height of the prism. How do you get the area of a triangle? How do you get the area of a triangle? Rhea?
Fair question. Do you have to put a capital B?
Yes, you have to put a capital B, as opposed to a little b that we use in a parallelogram or a triangle, which is representing the length. Good question. All right, so my last question was, how do we get the area of a triangle? Because that's what our base is. Mason?
1/2 times B times H.
1/2 little b times h. That's the area of our base, a triangle. And then we have to multiply it by the height of our prism. What's the height of the prism? Yes? 9 centimeters. So now the tough part is picking out the dimensions of the triangle, because you got to look in different places to find the base length and height of the triangle. And remember, they have to meet how? In a triangle, the base and height meet at what, Julian?
On 90 degrees.
90-degree angle. So do you see the two dimensions of the triangle that meet at 90 degrees? What are they? Callie?
They're 12 and 16.
12 and 16, they're shown right here, yep. And then the height of the prism was 9. So we multiply these together. Point.
22.
Oh gosh, you did a lot at once. What's this equal to?
96.
96. Capital 12 is 6 times 6 is 16 is 96. 10 times 9, and you got,
3, 4.
do that again. I think you did something wrong in the second part of multiplication. 9 times 6, here's a 5. 9 times 6 is 54. Here's a 5. 9 times 9 is 81, and 5 is...
Oh, I did 9 plus 9 is 18.
Alright, there we go. 864, is that right?
Yeah.
Okay.
Yep.
Exactly.
Is the value. That's okay. Alright. Any questions about that? Okay, we gotta look at the surface area now. Surface area is the outer covering. You had practice with it yesterday. So, can anyone see what this is? What is this picture of? It's that, but it's
Fold it up. Unfold it.
unfolded. It's unfolded, right? Here's the top. Here's the 16 centimeter side. Here's the 12 centimeter side. And what is this side?
Backside.
The 20.
20 centimeter side. It's this back side over here, which is that dimension. So this is 20 centimeters. Okay. Go ahead and sketch this out quick. Applause while you sketch. Okay, so when we look to find the surface area of this, we have to do basically the same thing that we did yesterday, which is find the area of each face and put them together. So we know that we'll have 2 of these bases, right? They're the same. So we'll have 2 of the bases, and then we have to add in the lateral surfaces. You can find the area of each piece. You can find the area of this one. You can find the area of this one. You can find the area of this one and add them all together. But there's kind of a slick way to do that, to find the area of all of the faces at once. Can you think of a slick way to find the area of all of the faces at once? Good grief. Lise?
You put both 29 times 16 plus 4 plus 1.
Yeah, can you look at it and just see, well, when we unfold them, it makes one big rectangle. And the length of this side of the rectangle is 16 plus 12 plus 20, and multiply it by 9. So the 16 plus 12 plus 20 is basically the perimeter of the base times the height of the prism. So when you see this a lot of times, in the textbook you'll see the perimeter of the base times the height of the prism, because it makes this big rectangle. See the big rectangle?
Oh yeah.
Capone? Yeah, see it. All right, so let's do this. First of all, let's talk about the triangles. Did we already find the area of the triangles?
Yeah.
Yeah, we did when we were doing the volume, right? We found the base area. What was the base area of the triangles, Ethan?
It was 1/2 times 16 height.
Yeah, and we calculated it, and it equaled...
Oh, 800.
This is the area of the base.
Oh, the 96.
96, right? Yeah, we calculated it over here. So we have 2 of those, plus we're going to find the lateral surface area. We can take this perimeter, the 16 plus 12 plus 20, and multiply it by the height, which is 9. All right?
Is it always gonna be like open up like that?
What? No, you have to do it in your mind. You got to open it up in your mind. 2 times 96. Help me out here. What's 2 times 96, Alec? Thank you, Alec. 16 plus 12 plus 20. What is that? 16 plus 12 plus 20. Mason?
48.
48 times 9. So we got 192 for the area of the bases, plus 48 times 9,
230.
432.
Little on it, bit
Yeah,
less.
432.
And then we add those together. 24?
Yes.
What are the area units? What are the area units here? Margaret? Yep. Okay, so questions?
No.
Okay. All right, we got to pause for